Hi. Guess what? I actually feel like an Indian student now. Do you know what? Well, my JEE main exam has been postponed by 2 months. It was supposed to happen starting from 21st April, which is approximately 2 weeks from now. And now it's in starting from 21st June. Wow. Now I actually know how people feel when things get postponed, exams get postponed. Yeah. Anyway, so now I'm taking a small break right now for some time, and so I decided to make a video. I actually had made this video some time back, but like I realized there were a lot of problems with it, and I realized that I don't have time to fix those, so I just removed it. And I'm going to be recording the video again, but the idea is the same. So let's go for it. And it's basically like Feynman Part 2. So that video has got a lot of views, so this one's for you. Alright, so this is the question. Integral from 0 to x minus t plus 1 into gt dt is equal to x to the power 4 plus x square. Find g of x. Now the first thing you might notice in this integral is that there is no plus c. Wait, just a second. There is no plus c. Well, that is because this is a definite integration, so there is no need for plus c. Okay, so now just remove that. Anyway, so now how do we solve this question? Oops, sorry, wrong color. Yeah. Anyway, so now you might remember Feynman's trick. You can actually differentiate both sides. So if you d by dx, because x is the variable of the left side, is equal to d by dx of the right side. Now this is not Feynman's trick. The Feynman's part will come in a while. Now let me just simplify the left part. We can use a sum rule in division like this. So integral from 0 to x into gt dt minus integral t minus 1 gt dt from 0 to x. And now if you look at it, x is not a function of t, so with respect to t, x is basically a constant, so you can take x out over here. So this will make it x integral from 0 to x gt dt and minus this thing over here. Oops. Yeah. I'm not like writing the right hand side over here because right now we're only looking at the left hand side. So now if we differentiate both sides, what do we get? So we can, for differentiating, we can use the sum rule or the difference rule, as some might call it, but the sum rule and difference rule are basically the same thing, because you can make this plus and this one plus and minus. It won't make a difference, so I'll just keep it as how it was before because I find it more comfortable that way. But if you want, you can just put plus over here and just multiply it by minus inside the integrand. And so if you differentiate this, so you can, so the derivative of d by dx of the left side is basically the derivative of this thing minus the derivative of this thing, and I'll just put minus over here, minus. So what is the derivative of the left part? Well, using the product rule, it is basically the derivative of x, which is 1, into integral from 0 to x gt dt plus, I'll keep it down, plus x into x into derivative of integral of gt dt from 0 to x. Now that is the Feynman part. So that is basically g of x, and now as it is only x in the numerator, so we can keep it like that. I'll explain the other case in a while. So minus, this is the left part, minus the right part. And now this is directly, can just derivative of this is basically the integrand, put x instead of t, so that keeps it x minus 1 g of x, and that is dl by dx is equal to dr by dx, which is equal to 4x cube plus 2x. So that's basically 4x cube plus 2x. Now you can simplify this by writing integral of g t dt from 0 to x plus x g of x minus x gx plus gx, and these two cancel out, is equal to 4x cube plus 2x. Okay, so now this is what we have. So now we'll differentiate again, because we prefer not to have integrations in our equations. They're just more convenient. So we'll differentiate again, and this time we can directly remove this by differentiating. So g of x plus g prime of x is equal to 12x square plus 2. Oops. Anyway, so that's 12x square plus 2. And now it can be seen that g of x is a polynomial, because every expression on the right hand side is a polynomial, and the derivative of polynomial is a polynomial. So, and now if you have, suppose you have gx as a n x to the power n plus a n minus 1 x power n minus 1 and so on, then g prime of x is a n into n x to the power n minus 1 and so on. If you add them up, the maximum degree of the polynomial of the expression is n, and the maximum degree of the right hand side is 2. So we can see that g of x is a 2-degree polynomial or a quadratic equation. So I'll just move this. So we have g of x is equal to ax square plus bx plus c. G prime of x is equal to 2ax plus b. You add them up, you get ax square plus 2a plus b into x plus b plus c is equal to this little thing over here. Now if you equate the coefficients, you get a is equal to 12, 2a plus b is equal to 0, so b is equal to minus 24, and c is equal to, well, b plus c is equal to 2, so c is equal to 26. So there you have it, g of x is equal to 12x square minus 24x plus 26. And this is the answer. Okay, so I had told that I would explain what I meant by directly put x in. Like suppose you have this expression g of t dt 0 to x, and you have to differentiate this with respect to x. What would you get? So while doing this, I told you can just directly put x in and you'll get the answer. Now I'm going to explain what I meant by that, and like why you can't directly do it for other functions per se. So let's suppose you have 0 to x square g of t dt, and you want to differentiate this with respect to x. Well, for that, if you do it, you'll get the answer as 2x into g of x square. Now why do you get it like that? So well, now let's say that you have, suppose, integral of g of t dt from 0 to x is equal to some function f of x. So basically f of x is the antiderivative of g of x actually. So, and now if instead of x you put x square in the whole expression, you get 0 to x square, or if you want to generalize it, you can make it f of x g of t dt is equal to f of x. And now you can directly differentiate it. So you get d by dx of, I'll call this I, of I is equal to f prime of f of x into f prime of x. This is chain rule, like we all know it. And now we know that f prime of x is basically g of x, right? So f prime of f of x is basically g of f of x. So if we put f of x as x square, so we get g of x square, and into f prime of x, which basically gives 2x and g of x square. So that's basically it, what I meant when I said you can directly put x, and in these cases you can't. Okay, so that's it for this video. I really hope you enjoyed it, and well, I thank you all for love you people have shown me. We have now crossed 150 subscribers, and my Feynman video has over 200 likes and nearly 12,000 views, which is a lot of views. I never imagined getting that many. Feels good. And so please like, share and comment on this video, and subscribe to my channel, and obviously share it to people who you think might actually enjoy my type of content. And again, subscribe. It really means a lot. Thank you.